This meeting is being recorded.
So welcome back, everybody, from your weekends. Today, well, right now on GitHub, I'm in this topic 2 models and evaluation folder. We'll talk a lot about different models today in class and evaluating them. And there is some news over the last week about OpenAI releasing a couple new models for people to play around with. We'll talk about those models a little bit and what's cool or interesting about them. And it also neatly ties into what I was hoping we'd talk about anyways, about evaluating and how those models were evaluated. And so it'll give us a good excuse to talk about that stuff. Maybe before, let me refresh this webpage real quick. Before going into that, comments on homework stuff. So I just have this little aside over here. Let's increase the font one more. About so far, about half the class has submitted the homework that was due last night. It's okay if you haven't. In general, I hope to be very flexible about the due dates. And I haven't had like a super clear, strict policy about things yet. I think this Sunday sort of timeline seems to be working well-ish. So I'll continue to have the due dates sort of nominally be on Sunday, but you can have up to 2 days grace period until Tuesday, and you can submit it without any penalty grade-wise up until Tuesday. Maybe the advantage of submitting it early is that probably I will only look at homework assignments once per week on Monday or Tuesday. And so if you get things submitted early, then you get the faster feedback turnaround time on things. But if you don't get it submitted early, then no penalty grade-wise. You just will have to wait a week for me to take a look at it. And then again, so reason Tuesday, you get to ask questions in class here or office hours. Tuesday morning, you can come talk to me about things then. And if for whatever reason after Tuesday still not submitted, a -1 letter grade penalty for each day late after that. And I intend to be like super flexible about extensions on things. So again, the purpose of this class is really to for you all to be having fun about things, to do stuff that's fun for you. And if for whatever reason it would be more fun for you to submit things on a Wednesday or a Thursday, then I'm happy with that as long as you just let me know in advance. Really, the only purpose of having some sort of policy like this is to have some motivation for you all to not fall behind on stuff. All that said, any questions about the homework from last week, the RAG, retrieval, augmented generation stuff?
Yeah, was the article DB class supposed to fetch the text content from the URLs?
Yeah, so the question is, this article DB class, is it supposed to fetch the text content from those URLs? The answer is that it has a function in there that, given a URL, will go out to the internet and pull it back in. But I implemented that for you, and so you didn't need to touch any of that. That used a bunch of, I don't know, potentially awkward stuff to just get installed and get working. The stuff that you were supposed to implement, like you already had the articles in the database, and so just access the stuff from the database. Is that?
I came across a few problems.
Okay.
Trying to use that function that like took the URLs and scraped the content. One was that like when I called that function, it was able to actually get the text content from the different URLs using like the meta HTML library. And then also the meta HTML.
I'm going to pause you for a second. So the question is, the meta HTML library sometimes not able to scrape the actual content of URLs. And so the reason for that part in particular is that there are currently no good tools to extract like the contents of web page from or the text of a web page from a URL. There's different trade-offs that all the different tools that make or that exist, different trade-offs that they make about if you've taken some sort of like machine learning course before, the keywords are precision versus recall. Like, do you do you want to include ads in the web page? Do you want to include like links, like header information, like extra article, extra information like that? If you're including more stuff like that, you would have a high recall. If you are being more concerned about like only including stuff that very, very definitely should be in the article and not other stuff that's related to having a high precision, most tools focus more on the recall, get everything. The meta HTML library, it's something I made with some students a couple of years ago. For various reasons, it focuses on the precision of ensuring that you only get content that is guaranteed to have been part of the article. And for some web pages, you're not going to get some content. So there are likely to be some web pages that it doesn't work for. I don't know if that answers your question.
Is the meta HTML supposed to be the same as what we see in the .db files?
Is the output of meta HTML supposed to be the same?
Like the find URL function.
Tell me more about what you're trying to say.
So in the article DB class, there's this function called add URL, and then I suppose like this calls meta HTML parse and simplify meta, which uploads like the pure content from the article into the database.db.
Okay. Yeah.
But when I ran this, and then looked at the database, it wasn't able to extract the actual content from the URL that I put in. Is that supposed to?
So there are many URLs that this will not work on, and in general, it's impossible to write one function that's going to be guaranteed work on any URL. I'm going to quit out of this for a second. One thing I didn't do last time is you can interact directly with these SQL databases with the SQLite 3 command. If you're familiar with SQL at all, this is like the most convenient way to interact with these databases. So the ragnews.db, this is the database I want to look at. And .schema tells you the structure of the database. So this create virtual articles right here. And there's the text field right here. If I do a select count star from articles, there's going to be, okay, there's 12,000 in here now. But if I do where text is not null, so this is like things that actually exist, only 4,600 of those actually have text inside of them. So there's something like 8,000 or so URLs that it has tried to scrape, and for whatever reason, it has decided that there's no text in there, and that's expected behavior. So 2/3 of the web pages that I have scraped do not have any content for this purpose. Yeah.
For like the website, there's like a bunch of URLs inside like updatedb.sh, which was inside the repository. And then for me, or Claremont, or this one works too, it's like it wasn't able to get a lot of the text for like almost all the URLs. The only one it was able to get from you was
so none of these are actual news articles.
Okay.
So these are expected not to get any text here. These are all like the home pages of different newspapers. And this recursive depth here is saying that it should follow all the links inside of here up to a 5, like, we'll go ahead and take a look at tslnews.com, see whatever the news is for today. tsl.news.com. This is not an article right here. This is a thing with a bunch of articles inside of it. But if you click on this first link here, this is an article, and the text of this article is all this stuff right here. So this is the stuff that gets put inside of the database. The recursiveness about it is that we'll click one link, and then from here we'll click one more link, and we'll keep clicking 5 links deep, trying to explore large portions of these websites, but there's no like guarantee that we're exploring all of these websites. And in general, like actually crawling the internet is a fairly complicated task. This is a very, very like super dumb web scraper that I have here. But yeah, the main thing that it does is it just tries to make sure that it's getting articles and not things that are not articles. So it does not want to collect something like this because this is not an article right here. Even if we went to something like in the here, news about Claremont McKenna, this is also not an article right here. There's like an aggregation of a bunch of articles. So this would not register any text at all. Okay. Yeah. Yeah, no.
Is it true that in order for the doc tests to be run in the GitHub Actions environment, that meta HTML would have had to be cloned and then do a partial checkout for it to be cloned in a reasonable size within that GitHub Actions environment?
Yeah, that's a good question. So the question is that in the code that I gave you, ragnews.py, there are a bunch of test cases, doc tests here that use things like this add URL function. And in order to have the test cases actually run on GitHub Actions, you would have to have the libraries and everything installed under GitHub Actions. That there's some complicated-ish things going on there, things that you have to figure out to get that to work. But this requirements.txt right here, this should have everything inside of it that you need for to get it working on GitHub Actions with the right Python version. So yeah, in order to get the doc tests, you didn't have to on like your own setup down on your computer get like things like the meta HTML working, but in order to get the doc test to pass on GitHub, which you should, you'd have to get the things like meta HTML working on GitHub. Yeah.
Is meta HTML a valid PyPy?
Question is it a valid PyPy package? So this is a interesting question worth talking about for a second. Python has this ecosystem of distributing packages, pypy.org. When you do something like the pip install, by default, it searches this repository. It's not a Git repository, but it's like a package repository to install things. And the question is, one level of the question is this meta HTML library published up here somewhere? The answer is no, that it is not available on pypy.org. But it is available on Git, and you can install these packages directly from GitHub, so, or directly from, let's see, where am I? So there's this meta HTML folder right here. Is a submodule of this project. If you check out the submodule, then you'll have access to it. And here inside of meta HTML, if you do pip3 install dot, so dot for the current folder, then it will install from the Git repo instead of from PyPy. So instead of doing something like pip3 install meta HTML, you clone this repository and then do pip install dot on that folder. This is getting into things that are, I think they're like important software engineering things. They're things that definitely come up in any like reasonably sized company all the time about installing things from different locations. And so I think it's very useful for you to get into the, to understand how to do something like this. It's also not the most important part of the assignment though. So if I would recommend you trying to get the test cases to all pass as written. But if that's taking you more than, I don't know, 2 or 3 hours, say, then I will not be offended if you comment out, say, the doc tests that that mention this add URL function. So yeah, I guess I recommend trying to do it. I think it's a skill that will be very useful for you. But again, if it's taking more than, say, 2 or 3 hours for you to get it to work, then it's fine to comment out these things involving the add URL function, and then everything will just be testing the code that you wrote. Good questions. Any other questions about anything about the homework?
Just to confirm, just doing like carrots or whatever.
Yep.
And then like the reason why it's uncles, is it because like these are wrong when you're doing it yourself?
Yeah, so a lot of questions to unpack here. The first of it is just like, what is the reason why this stuff here is purple instead of red, like my other things are up here? Just the most literal answer to that is just that I have special syntax highlighting rules in my Vim over here that is these doc tests should be highlighted in purple instead of in red. If your highlighting is different for whatever reason, using VS Code or whatever, and it's not highlighting these things, that like the syntax highlighting is unimportant. But the real question here about is like, what exactly are these doc tests doing and what are they for? And again, like here, when I'm gonna create a new terminal real quick, make this bigger, Python 3. Every time you're in an interactive Python environment, interactive meaning that I can just type in Python commands and it tells me what the output is, whether it's a syntax error or I can't let go of that shift key. There we go. 1 + 2 = 3. Actually doing the math. This is like anytime you see 3 carets anywhere in the world in your life, that should be telling you that the stuff over here is Python code and it's in a Python session. And so it's just like this line is running. And then what is the output of this line? It has no output because in Python, when you assign something to a variable, that has no output. But then you can do some sort of function on that variable. So maybe the absolute value of x, and that does have some output down here. And so one of the nice things about doc tests is it allows you to write relatively complicated tests that look just like a session that somebody using Python would be walking through to just test exactly how your library is working, what it's doing. And so we can see without actually running all this code that if everything's installed correctly, what it should be doing. So these 4 commands right here, it's just like they were copied and pasted into Python over here. That's exactly how the doc test command works, is it starts up one of these Python 3 interactive sessions and it copies these things in over to the left-hand side one at a time, and it just checks to make sure the output string exactly matches. And if it matches, it passes the doc test. So the way to think about these things when you see them is that this is like somebody has actually typed all this stuff out into a Python interactive session, and this is their output that they get. And so this is both a way for you to understand what the library is doing. That's the most important thing, is that it's a way for you to understand what somebody else's code is doing. Or if you're writing it, it's a way for somebody else to understand what you're doing. But then because documentation gets out of date really easily, this is a very nice way of doing documentation because it forces us to have the documentation stay in date, because it forces us to make sure that the outputs here always match whatever the output of the code is. Did that answer your questions somewhere? Good questions. If you do have any more questions about anything about the homework assignment, then happy to stick around after class, talk about them for a bit, or office hours tomorrow, or I think there's a handful of GitHub issues that I haven't taken a look at yet from the weekend, but I'll feel free to post that and I'll take a look at it sometime today. Sometime today I'll go through whatever's waiting on GitHub still from the weekend. Okay, coming back over here. Okay, another sort of meta-ish thing is that last time I posted this survey form about just how class is going, and for the speed of the lecture material and difficulty of homework assignments, everybody said pretty much just right. So that's basically, we'll keep going how we're doing with things. At some point in probably like 2 or 3 weeks, we will shift gears to do less like coding stuff and more mathy stuff. And so at that point, things might change about the speed of things and the difficulty of things. But we'll see. Also, good suggestions about different topics people wanted covered in different things. We will, I think everything that people mentioned they wanted covered, we will definitely have time in the class sometime to cover those things. Okay, any questions about anything in the past or administrative before getting started with new technical things for today? Okay, so Summary, last time, RAG, improved response accuracy. Again, one thing too that I haven't said yet today is that you're gonna have a project at some point in this class. That's like the main thing that your grade is based on. And the simplest, most straightforward thing, the thing that I expect most people will want to do, is to implement somehow RAG on some interesting data set of your choice, some interesting task of your choice, and get some cool results going with that. This is like the most straightforward, interesting project to do. And so you guys can start thinking about your future projects. In a couple of weeks, I'll talk about that in more detail, but this is a good thing to start thinking about. What would be some fun things for you all to do that involve this retrieval augmented generation somehow? But this week, what we're going to talk about, and people asked this sort of question a lot last week and the week before, is that how do we actually know that our models are doing well? Like if we do all this time prompt engineering or whatever we're doing, how do we know that that was worth it? And the answer is that we are going to benchmark our models. And so this week we'll be talking about how do we benchmark those models and how do we actually measure that we're making improvement and actually make that improvement. Got a lot of things to talk about this week related to that, but I'm going to jump down here to the bottom to give us a highlight of why we're talking about this, how that's going to relate to your assignment. And the answer is that last week I created this data set, which I call the Harry Trumpet data set, which is a data set about Harris and Trump and all the things that they have said and done. And you will use that data set to evaluate your model and measure whether your prompts are good or not good. We will see as we're talking about all these things that the meminess of various data sets and things is important, or it's common in the LLM world to have things that are somehow trying to be viral. So this is my attempt at a fun name for our data set. But we'll get to that probably not today, probably next time talking about that. Okay. So in order to start talking about that, or one of the things that we're going to start talking with is last week, OpenAI announced 2 new models that are available for people to use, this O1 Mini and this O1 Preview models. And they make all sorts of claims about why these models are better than previous things. And so we're going to dig in a little bit into the different benchmarks that they're using to make those claims. I'm curious, how many people, has anybody here like played around with those models at all? A handful of people? Okay, that's good. I have not, that OpenAI has not given me permission to use these models yet. So this is all, everything that we're talking about is based just on their announcements here and other hearsay things, which is the best kind of, hearsay is the best kind of news to have about things. So this link right here, where it's going to take us, learning to reason with LLMs. So this is their blog post about what they've done. And there's a couple of things that I want to highlight through here, but we're going to not do it all right away. The first thing that I want to just jump into is this graph right here. And I'm going to spend a lot of time on this graph and critiquing this graph. One of the things that all their blog posts is making a big deal about is that there's this trade-off between like training time compute and testing time compute, and they found a new way to spend compute time during testing instead of training. And these 2 plots here, I think, are some of the best demonstration of that they have. The first thing, though, that's obvious to anybody, should be obvious to you all looking at this, is that a plot like this on any like intro science course would get you a failing grade because there are no, for example, units here on the x-axis. Like we have this training time compute, at least tells me that it's on a log scale, but it doesn't tell me like any numbers down here of seconds, minutes, hours, days, whatever it takes to get this. And later today, in a little bit, I want to share a trivial algorithm that also has this particular performance trade-off. So this thing here that they're making a really big deal about is my argument is going to be that this is like a really bad thing to be proud about. That's the highlight. We'll get to that as we get to that detail. But first, there's more details that we have to cover. Always more details that we have to cover. One of the weird things about this sort of subject is because there's so many things going on, there's so many interrelated things that we have to cover before we can get to whatever it is that I actually want us to talk about. So first thing that we have to talk about is this OpenAI drama. So very little information released in this announcement. Again, example of that little information being released is not having these proper timescales down here. Makes it very hard for me to judge whether this is actually like useful or not. And if you haven't heard about, like, been following the news super closely, like OpenAI used to be famous for publishing lots of research and actually sharing their results. Now they're very famous or infamous for not publishing anything, just putting up these blog posts that would not pass peer review anywhere. Elon Musk famously is against them for this. Lots of people against them for this. Here's just some tweets. Change your name to close AI, and I will drop the lawsuit. He has an ongoing lawsuit with OpenAI because he's gave them a lot of money, $100 million as like seed funding for being a nonprofit, and then they switched to being a for-profit company. More memes from him. Here's the I don't know, fun history of the things that in May, he started suing them. Then OpenAI released a bunch of his emails, and so he stopped suing them. But then just a month ago, he decided he wanted to sue them again. So nobody really knows what's going on there. But I think this quote is a good summary of like what's going on. I'm still confused as how a nonprofit to which I donated $100 million somehow became a $30 billion market cap for-profit. If that's legal to go from a nonprofit to a for-profit, why doesn't everyone do it? I think there's a lot of people in the machine learning world, research-wise, who feel sort of betrayed by OpenAI that way. Well, it's a rhetorical question. Yeah. And I think everybody agrees that what they did is probably like legal in some sense, but like should it be legal is really the bigger question. Okay, but that's sort of background-ish thing of like what's going on. Actual technical background of what's going on is this chain of thought technique. So these OpenAI new models, O1, mini, O1 preview. Again, there's not a whole lot of technical detail, so we can't really know what's going on, but everybody thinks that what's going on is this chain of thought technique. And chain of thought has been around for a long time, and I want us to talk a little bit about what it is and how you all can use it, how you all can use it outside of these new models, and why it's good. So there's this historical overview right here. If you want more detail about what's going on than what we'll cover in class really quickly, this is the thing to look at. A lot of students often, I think, fall into the trap of trying to read like the source papers behind things. For a lot of other fields, that's a good thing to do, actually read the source papers behind things. But for this particular field, because things are moving so fast, if you try to read the source papers about things, you will lose a lot of context about what's actually like going on and people are talking about. So these are like, I don't know, they're useful for me to read. I don't think they're useful for you all to read. These blog post-ish things are the better way to get like up to date on what's going on. I put these here because it's just useful to have this little timeline here. These are probably the 4 most famous papers about this chain of thought reasoning. I'm going to take us over to look at some key figures here in a second. But the timeline of these is the important thing. That like the date between the publication of this first paper right here and the second paper is only 2 months away. Most fields that have like so like in the econ department, people over there submit to journals. It's typical for a paper to be submitted to a journal and not published for 2 years. Here, these papers are released, and then basically instantly people are doing new stuff with them. So yes, pace of research in this field much faster than other fields. Here, these 2 teams, it's basically the same people working on these 2 papers, so it's not maybe too surprising. But these other 2 papers, which are actually even, well, as we'll see in a second, more important, this one right here is the most important, most famous of those papers, made by a totally different team. They just read this paper right here in, was that January, February, May, and then in April, 2 months later, published their new totally groundbreaking paper right here. So what are these papers? What are they doing? I'm going to switch over here for a second so we can see these papers. And anytime you're looking at a paper, so in a second, I'll zoom in here so we can actually see the text. But anytime you're looking at a paper, the first thing that I always notice is the formatting of the paper. In the machine learning world, text natural language processing world, there are about, I don't know, somewhere between 5 to 10 like main super famous conferences, depending on how you count. And they all have different formatting of how the text goes. And I can tell just from looking at the formatting of the paper, like what to expect from it. Is it going to be a math heavy paper or like a not mathy paper? Both of these two venues are published in the like most famously math heavy venues. On the left hand side, this formatting up here is a NeurIPS publication. This like double bar up here with one column tells me it's NeurIPS. This paper on the right hand side is an iClear publication. The acronym ICLR over here is the cool kids pronounce it iClear. I can tell if somebody is a machine learning person or not by the way they pronounce this acronym. If they say ICLR, I know they're not in the community. If they say iClear, I know they might be in the community. So you all should say iClear when you're talking to people. And again, the next thing, so after getting a sense of like what to expect from the paper, the next thing I look at is who are the authors of papers and particularly where are they coming from. So both of these papers here coming from Google Research, the Brain team. And anytime I see a paper coming from any industry lab, I expect at this point, there's going to be zero math involved in the paper, but it's all going to be about just like a lot of computing on things. That's sort of Google, Microsoft, Facebook, whatever any of those big industry labs, their main contribution these days is just having a lot of computing that us normal people don't have access to. Another thing that's weird about machine learning these days is it's very common for papers to have like 10 authors on them like this. So it's super unclear like who actually did anything on these papers. If it's a shorter author list, like 1 or 2 people, then I might pay attention to the authors. But when it's a big author list like this, I just think, okay, I don't care who any of the authors are and move on. Other people are different, but I don't care any of the authors if it's a big author list like this. Okay. Now on to some actual technical things. Those are all things that just like instantly go through my mind as soon as I open up a paper about things. I'm going to move the right hand thing to another window. There we go. And take a look at this paper right here. The first thing that in the machine learning world, papers are always judged by their covers, and there's always like one key figure that is somewhere in the front of the paper, either at the bottom of the front page or at the top of the second page. And even before like reading the abstract, everybody in the machine learning world just looks at this key figure and reads this key figure to try to understand what's going on. And for vast majority of large language model papers, just understanding this first key figure is really all you have to do with a paper. And unless you're trying to do like real nitty gritty research, you shouldn't read beyond that and just look at this key figure and then move on to reading other things because there's so many things to read. So this key figure here, what is it telling us? On the left-hand side, we have this standard prompting. There's this QAQ, and there's some sort of like puzzle here. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? And the answer is 11. And so this is like a elementary school sort of word problem that you have to figure out. And their prompting is, this is sometimes called few shot prompting, where you give it a couple of examples with both the question and the answer, and then you ask another question over here, and you try to have the model output what the answer is. And so on the left-hand side, this is released in 2023, I believe. The left-hand side is what people used to be doing, say like 2 years ago. And then this paper introduced this idea of chain of thought prompting. The idea of chain of thought is that if we, instead of just having the model here, instead of just giving it an example of using the answer over here, if we give it an example of how it should be reasoning about things, like putting in some basic math equations, like basically telling it to show its work, then that'll make the model want to show its work in the future and be more likely to provide the correct answer of things. So this idea of chain of thought is something you can do with any model. Doesn't matter what it is, whether it's the ON Mini, ON Preview, whether it's something super old like GPT-2, any model can do this chain of thought that it only happens at the prompting level. And again, the key idea here is that you provide some examples of having it show its work, and then it's going to hopefully show its work, and that'll make it more likely to get the right answer. Any questions about anything about this paper before we move on? Does this feel like makes sense, doesn't make sense, magic, not magic, standard engineering? Obviously, tell people to show their work. Everyone's still on the weekend.
For people in 2022 thinking themselves that they hadn't come up with this before?
Yeah, this is a good question. This is a good like sort of meta question, the sort of thing that's great to be thinking about while reading these papers, especially older papers from 2 whole years ago, or even 1 whole year ago. This paper is not just like what is the technical contribution, but what is the like how are people thinking about it? How did people react to it at the time? And I think the answer is that people thought that it was ridiculous that this could work. Nobody thought that this would work because, like, I don't know, it just seems like a stupid thing to try. And a lot of the things that have been like turned out to be very useful with these large language models have been very, very stupid sort of things. Actually, this particular paper right here, I think, or this technique, I think 4chan invented it. Most of these like LLM sort of techniques come out of like 4chan, and then the authors of these papers, maybe they were the 4chan anon who came up with it. I don't know, but my sense is that there's a lot of like laundering credibility from 4chan into like an academic publication like this and putting the right veneer on it so that it can be cited. Yeah, so this is like here, I don't want to say anything bad about this paper. This paper here is super famous, lots of citations, very like career formative for all the people involved in it. So yeah, I don't want to say anything bad about it, but it totally like broke my expectations, I guess, about like what to expect. This is like the reputation of being the most math-heavy venue for machine learning, and there's not an equation anywhere. The only thing about this is like you ask the model to show its work, and it shows its work, and it does better. Since then, there's like more like mathy explanations about why this might work, which I'm hoping we'll get to like later on in the semester. But yeah, this is very surprising because of how simple it is. Yeah.
That's kind of like my question, is kind of why this is like intuitively based
Yeah, so it's a good question about like technically why is it actually being better. I think the intuitive explanation is exactly what you said. Like, oh, if a human were to show their work, then they would get better results too. So it makes sense that a machine showing its work is going to get better results. So that's sort of one level of the explanation. Another level of the explanation is that there's very little training data maybe of just going directly to a correct answer, but there's more training data with like, I don't know, Khan Academy or all these educational websites about showing your work on things. And so if you ask the model to show its work, it's more likely to pick up on good things in the training data. That's sort of the current zeitgeist about like why this technique works, is just like training data explanations. My take on it though, which again, I hope to go into detail later in the semester, is that this opens up more computational ability to the model, that there's like a fixed amount of computation that the model does per token, so like per word or per letter that comes out. And just by having the model output more tokens, it gets more computation available. One of the things that I haven't seen published in a paper, but I have seen like on 4chan, is that if you just have the model like output I am dumb 1,000 times before providing the answer, you're still likely to get more correct results out of the result. And that lends credence to the idea of this computation. It doesn't matter like what these tokens are in green over here, just the fact that it had more tokens available lets it do more computation, lets it get better answers. So I think the true answer is somewhere on those lines. Yeah, but good questions. I want to jump ahead to the next paper here, which is this even more famous paper, Large Language Models Are Zero-Shot Reasoners. And the main first thing to notice here is that these are not like affiliated with the same people at all. One person happens to be on the Google Brain team over here. But they were not on the original papers for the chain of thought prompting. And my understanding is that they started at Google Brain after Google Brain did their other papers. And they were originally at University of Tokyo with the other people here. But coming down here, the key figure here, again, the only thing that you should care about in these papers, if you're reading them to understand what like the current state of the art is this first figure right here. And they have these 4 different examples of ways to do prompting down here using this same example of Roger has 5 tennis balls, blah, blah, blah. Again, the few shot over here, this was the previous bad thing that people were doing, not doing any chain of thought. The few shot chain of thought, that's what the Google paper presented, that you provide some sort of explanation and in your answers, basically give it demonstrations of showing your work. And that got better results. But you still had to provide like some examples, question answer pairs in order to get it to show its work down here. The interesting thing about this paper, though, D down here, is this phrase, let's think step by step. They just appended this phrase to the output of the model so that it should do this let's think step by step thing. And that sort of prompted the model to do its showing its work thing without actually having to show a bunch of examples of showing its work. And so now all of the system prompts everywhere, including like OpenAI, Anthropic Claudes, they all somewhere include this simple phrase in here, let's think step by step, because this just gets much better results in the output because it shows this intermediate work down here. So those 5 words is the contribution of one of the most famous papers in 2002. Is just add let's think step by step, and it causes models to show their work, does this chain of thought sort of thing. Any questions about that? Okay. Yeah, I don't know. Yeah, what's there to have a question about? It's only 5 words. Like, let's think step by step. So that's what we do. If you want to improve your current models, that's one thing you could try doing, adding that to your system prompt of let's think step by step. There's not too much reasoning going on in the RAG example, maybe, but even in this like non-reasoning sort of examples, let's think step by step often improves results. So it's a good thing to always try including in your prompts. I bring that up though because these are all from 2022, so 2 years ago, and so this idea of chain of thought is not a new thing at all. What really is the sort of new thing about these OpenAI models is that it's just including that somehow in the O1 mini O1 preview models automatically for us. Coming back over here, if we scroll down, where are you blurring out for me? They give some examples down here of the models, and I'm just clicking on like the show chain of thought. It shows you the different somehow some of the step-by-step stuff that's going on in between here before getting the output. And it I think to the practitioners, people who are involved in this all seemed like a very obvious thing to try to do, that like this should obviously improve performance. Okay. Yeah.
Do you know if they're doing more than just adding like another prompt for them to be with the final answer? Like, are they like are they getting their loss from the final response and training the?
Yeah, so this is a good question. So the question is like, surely they must be doing something more than just adding let's think step by step inside of there for these new models, because they were probably already had that phrase inside of there somewhere. The answer is they are probably doing more. I think they're also combining this with something called rejection sampling. That phrase is not in their like announcements over here anywhere, but I'm going to talk about that rejection sampling here in just a minute and explain what exactly it is more that they're doing.
They're building a tree of chains of thought using courses and
Yeah, so that's what they say. So I think that is literally what they're doing. So the one of the things that's different here about all of these chains of thought things is that there's nothing here is involving training. This is all at test time, and so they like models are not specifically designed to do better on this let's think step by step. And so these new models are somehow specifically designed to like trained on being better with this let's think step by step. So that is definitely part of it. There's another paper, that last paper that I linked down here. I didn't look at it. It talks a little bit about like training time stuff with chain of thought. So that stuff too is all like in some sense old, but I don't know. I think it's definitely the case that none of the major models, some fine tunes, but none of the major models did anything with this up until now. But so I think that training time stuff is a big thing. But that doesn't explain, for example, the how they can trade off the test time stuff, which the rejection sampling is, which is sort of what Professor Bachman was saying is getting at. So I definitely want to talk about that in a second after one more like fun problem about ChatGPT. Has anybody heard of the strawberry problem before? And still can't do it, yeah. So like people have been talking about this model of strawberry. OpenAI is going to release strawberry anytime, and it's a sort of a joke internally to OpenAI because like their best models, they can't do something that seems like it should be trivial, like how many R's are in the word strawberry, and there are 2 R's in the word strawberry is what it always wants to say. And are you sure I count 3 in strawberry? And it still talks about 2 in strawberry. And the latest models still aren't able to solve this.
When it breaks it down, it gives me like a list of all the letters in there, and then still says there's only 2 R's.
Yeah, my sense is that at this point, OpenAI is just gonna make this a joke, and they're gonna intentionally include false things in their training data of so that anytime, no matter what, when somebody asks about strawberry, it's always going to give 2 R's. I think so. So the CEO of OpenAI, Sam Altman, he used to be the CEO of Reddit, so he's I don't want to say good at trolling, but like familiar with that sort of environment. And so I think he would have a lot of fun with somehow doing things like that. Okay, but so like actually into the benchmarks now. We're talking about benchmarks, and so like that's our subject for this week, into the benchmarks. Let's talk about the benchmarks. Actually, let's not talk about the benchmarks. A couple more high-level things. These are good links over here to if you want like an overview of what people are saying about the latest models, just like tweets from the famous, there's a list of tweets from the famous different researchers. This is a breakdown of different things that they might be doing. Over the weekend, somebody implemented all of the O1 stuff on Grok. And so if you want to use like a llama model or something that's an open model with the techniques that OpenAI is doing, there's just a Git repo right here that you can do something like this. Getting something like this up and running, trying it on something. This would be an example of a cool thing that you could do for a project in this class. But so yeah, these techniques are like sometimes people talk about like the moat of these companies, the things that other people can't do. Whatever, like this technique is not part of the moat of OpenAI. That this is something that's very reproducible and something that you can go on and do on your own with other models. We also talked a little bit about jailbreaking. People have already been able to jailbreak these models, get access to some of the internal stuff over here. And OpenAI, back to that like meme about being closed AI, is threatening to cut off anybody their OpenAI API keys if they detect they might be doing that. So I don't know, fun things to take a look at, but we won't talk more about that in class. I'm going to skip this thing, talk about the benchmarks. I want to do benchmarks for a little bit. Benchmarks. So how do we know that whether these like new O1 models are actually good or not good? And the standard way for all of these things is benchmarks. And there's way too many benchmarks these days on large language models in general to try to keep up with them. The most famous of these benchmarks is the MMLU benchmark. If there was one benchmark that would be like the benchmark to rule them all, this is what everybody thought it was. This website over here, Papers with Code, is the standard way to like track benchmark progress on things. So paperswithcode.com on this MMLU benchmark, first published in 1999. People were getting 2021, first published. I can't read my chart, what my dates are. But anyways, first tested on things back here, and the current state of the art Gemini Ultra is so this is Google's model, and bigger than we don't know how big the OpenAI models are, but presumably bigger, and it's the Gemini Ultra still beats this benchmark right here. GPT-4 down here with a little bit less. Anybody here interested in or used metacalculus at all? Heard of metacalculus? It's a website for predicting the future about things. They have a sort of famous prediction about this MMLU benchmark, a lot of various predictions on the state of LLMs and what they're going to be like in the future. And a lot of people in the LLM community, sort of adjacent to the rationalist community, these sort of like prediction markets, very popular in the rationalist community. So these prediction markets very popular among the people who are doing work in LLMs. And there's predictions that, so in 2024, and people are putting money on the line here. That's why people think these predictions are worth something. The best state of the art will be 80%, but we've already passed that in 2024 with the Gemini being at 90%. And there's a lot of these other benchmarks here. A couple of them I want to look at in a little bit, but a lot of concern about these benchmarks as well, because so kind of like how this picture is demonstrating, there's a lot of moving the goalposts in these benchmarks. And this paper right here is one that I want us to take a look at because it's very important for the OpenAI announcement and how they evaluate their systems. So I have it open somewhere, but I'll just open it up again. This is a paper evaluating GPT-4 on coding tasks and basically calling out OpenAI for more or less lying about how well they do. We have this is their key figure plot right here. And so they're evaluating OpenAI GPT-4 on a website called Codeforce on their coding tasks. And Codeforce has their problems divided up into 3 divisions, Division 1, Division 2, Division 3. And these problems are very similar to LeetCode problems in spirit. So if you've done LeetCode before preparing for like interviews, Codeforce is just LeetCode essentially. But one of the differences about Codeforce is that they have regular scheduled competitions and they create new problems from scratch all the time. And here are the performance of GPT-4, its ability to solve these problems. Blue is easy, orange is medium, green is hard over time. And sort of as expected, like GPT-4 does really good on the easy problems, gets the medium problems right half the time, and the hard problems right very rarely, like 10% of the time. GPT-4 was released in 2023. We don't know details about its training data, but it's pretty obvious from this and a handful of other like leaks and things that have happened, but the training data stopped at the end of 2022. And what we can see here is that on the Codeforce challenge. GPT-4 does really well on things that exist in its training data, and then it does really poorly on things that are outside of its training data. That are like newly created problems that GPT could not possibly have been trained on because it was they were created after GPT-4 was created. And I mean, it's still doing like moderately okay, can solve some of these easy problems, but the performance goes way, way down at this on problems created after September 30th, 2021 right here. OpenAI has not, they've made no sort of public statements about their performance here on the Codeforces data set, at least that I'm aware of. They certainly know about this. The authors here are all from Microsoft Research, who are all working very closely with OpenAI on various things. So this is like something that's like over coffee, the authors of this paper have talked about with the OpenAI people. But there's not been any like public statements about this. And if we come over here to the actual like statements here in OpenAI about why their new models are good, I'm going to do a search for Codeforces. And the very first thing that they're talking about here on this web page is their performance on Codeforces, and that they're in the 89th percentile of competitive programmers. Maybe they have updated their ability to like do these things correctly. But because this is basically like ad copy, this blog post, there's no technical details. There's no way for me to like verify that they are actually using this data set correctly now compared to before. I am very skeptical that they are doing things correctly. And this all seems like, to me, overfitting their test cases somehow, that they're basically doing this because they know it's going to get them a lot of media attention and not because it's the technically correct thing to be doing. Yeah. So there's a good question about the ARC AGI challenge. I got a link to that down here. There's so many of these benchmarks, again, impossible for everybody to keep track of. This ARC AGI challenge is one of the most famous challenges as being like very difficult for these language models to do. I got opened over here for us to take a look at. This is the format of the ARC AGI challenge. And so it's not a text-based challenge, but you have like some examples, usually just like 2 examples here of these sort of like pictures. And it's obvious to a human that if you see some like small challenges, small like, I don't know, changes like this, they're just putting a little blue dot in all these little triangles, making them squares. And so over here, we could figure this out. It's a little bit tedious to manually do it, but we could go through and do it and solve it. And these challenges are designed to be like trivial for your average high schooler to complete, these ARC AGI challenges. But it turns out that these machine learning large language models do very poorly on this sort of task. And there's a lot of, and maybe it makes sense they do poorly because this is like an image task right here. Large language models more text focused maybe, but there's a lot of ways to get the large language models to solve something like this. One of the current state-of-the-art solutions to this is to use GPT-4 to write code to solve this. That gets into some of the test time trade-offs here. But this is like the key famous graph that from this challenge, that there's all these other data sets over here, these blue data sets. Probably can't see the names, they're not super important, but the point is that after they're released, they get solved really easily. ARC AGI is taking a long time to be solved. We're not really on track to being able to solve this. And the ARC AGI people have a specific blog post too about the OpenAI Mini and these graphs right here, and how their opinion is that OpenAI is being intentionally misleading with their performance about things. Yeah, so lots of interesting data sets here that people are doing things on. I don't know, did you have like a detailed question about ARC AGI or?
No, so for the
Cool. Is this? Yeah, these sort of, so yeah, there's so OA01 preview, this is like their new thing that they released to be available to everybody. And then there's 4 teams that are significantly better than the O1 preview at what they're doing over here and in terms of their ability to solve the problems. This data set and all of the data sets that I have listed down here, I call them betterish benchmarks because they're not based on publicly available data in any way. ArcAGI, for example, has I think it's 200 problems held out that they're guaranteed never to release into the internet, so nobody can train on them. And so all of these are somehow betterish data sets. Yeah, let's talk a little bit more about, well, I don't know, any other questions about the stuff we've seen so far? Or questions that you have about anything? Okay. The big picture, step back for a second. One of the reasons, again, we're talking about all these benchmarks is that for your next homework assignment, you're going to be like creating or working with a brand new benchmark about things. And so understanding the different trade-offs, weaknesses of different benchmarks will be useful to get ground yourself about why we're doing things the way we're doing it when we're using those benchmarks. Yeah, let's see. So many benchmarks, worth clicking through, looking at those at least once. These ones down here are the ones that people are really caring more about these days. The language model arena one, I think, is super famous. So let's take a look at that one. Has anybody here played with the language model arena? A couple of people. So what this website is, lmarena.ai, is that it has space for you to type in your prompt down here, and then up above it shows the outputs of 2 different models. And so right here we can ask something like, how many R's are in strawberry? And it'll select 2 random models, pass those the prompt to it, and in this case, both of them get it correct. There are 3 R's in the word strawberry. The word strawberry contains 3 R's. And so we can rank the answers down here. I'll say it's a tie because they both got them correct. And here's a 4.0 mini, and GPT-4 happened to get both of those correct this time. So again, I guess that's the stochastic nature of these things, is sometimes they'll get things correct, sometimes not correct. But this website has a leaderboard of which things have been ranked the highest by different people. And so here's the different rankings. Maybe one thing that's confusing here is Grok with a K is different than Grok with a Q. This is a model made by a company founded by Elon Musk, totally unrelated to the Grok with a Q, which is a hardware vendor. But one way that you can you could improve performance on the homework is, say, by using a more powerful model, a better model, rather than the default model on a Grok. And we'll talk about that on Wednesday in class. Any questions about? Yeah.
I love this. Why are you testing to find anything better? Why do you think it's better?
Question is why I feel like they're better? Yeah, so it's a good question. Why do I call these ones betterish benchmarks? The answer is that there's not really a way to hack these benchmarks in the way there is up here. All of these benchmarks, MMLU being the most famous, but also that code forces, they have their data is on the internet somehow. And so if your model is being trained on the internet, then you're going to touch somehow that code or those benchmarks, see what the answers are supposed to be. And so we'd say that the model is going to be overfitting to those answers because it's in the training data somehow, or there's data contamination between the training and the test data. The betterish benchmarks, they somehow have some way of preventing that from happening. So the one we were just looking at, the language model arena, the way that that's happening is that like we're creating the actual data as we go on the fly, and it's a human who's evaluating whether something's better or not. It's not like there's an automatic evaluation. Live bench is a more closely related to those traditional benchmarks, but they automatically or they keep their code hidden or their test sets hidden, and so there's no way that to fake that. And here O1 preview is getting the best results here. So maybe that's evidence that they are not overfitting on the code forces. You can click on like the coding subcategories they have, and but if you just look at just coding things, then now Claude 3.5 is much better, and actually O1 preview is worse than GPT-4o on coding tasks. But OpenAI actually advertises like the reason to use O1 preview is because it's better on coding tasks. But independent evaluators have found that GPT-4 is actually better on coding tasks. So that gives me some like suggestion that OpenAI is overfitting somehow on their O1 line of models. But yeah, I don't know. There's too many of these things to try to like make any attempt to understand them. You shouldn't try to understand them all. You should have maybe like one or two that you like for whatever reason that you go to when you're doing your own model selection about things. This ARC AGI is one that you should probably know about. The MMLU one is one that you should probably know about, as it's like famous for the previous standards. But then like all these different betterish benchmarks down here, whichever ones people use for their task is just sort of like I don't know, matter of taste. I don't know if that answered your question anywhere in there. Yeah, it's a good question. Happy to continue talking about random stuff for 5 more minutes, unless anybody else has like specific questions about things that you're interested in. Yeah, Ainsley. Yeah, so we won't go over the homework in detail today at all. Don't do anything for the homework before Wednesday. The things to do for Wednesday are just to fiddle around with some of these links and explore some of these benchmarks. But brace yourself. On Wednesday, we will go over the stuff for the next homework. Yeah.
I have a random question about just GitHub stuff in general.
Yeah.
So on the rag news, on the example rag news thing you put up, that GitHub in the git ignore file, there's something that says like has the $db.
Yeah.
Is that telling it to ignore all DB files? Or like what?
Yeah, so I'm opening it up right now. So I'm in the rag news folder right here, and you're talking about there's the git ignore right here. And if we open up git ignore, inside of here, there's this star.db. And this is in fact telling Git to ignore all of the .db files. The reason for that is, I don't know, it's sort of a matter of taste, whether you do something like that or not. But these DB files, these SQLite databases, they are all binary blobs, we call them, that there's no like, they're not text files. Git is designed for text files, tracking diffs between text files. And anytime that there's like binary files that I want added into a repo, I want to be very careful that I'm adding the right binary files. And so by adding it to the git ignore, it just means that if I do in fact want to add, and actually there should be some changes here to ragnews.db because I updated it this morning with new databases. Anytime I want to actually add that to the system, it says like it's not going to do it unless I add this -f flag. And then if I do that, then it actually adds it, and then I can upload it. And that's what I did for you all to have access to it.
I was just confused because that's what I assumed it meant, and then there were still like
they were still in there.
files.
Yeah, yeah.
Okay.
So yeah, the git ignore is not like a security thing. It doesn't actually prevent things from being added. It's just makes it harder to accidentally do it.
Or things you really don't want to add any stuff.
Yep.
Okay.
Good question. Cool.
I guess also for doc tests, using seed with the is the C parameter still doesn't guarantee determinism? Do you want us to like retry?
This is a good question. So, dash and doc test of what's it called ragnews.py. The answer is that. Oh, and I have to. The question is that when running the doc tests on these things, some of the again, some of the functions are totally deterministic, and so it's guaranteed to work. Some of the functions are not deterministic, and so it is not going to work. We made some attempt